Imagine a world where GPS does not work, and satellites that predict the weather no longer exist. This doomsday scenario could become reality unless we do something about the space junk orbiting the Earth. As shown on the left, there are over 22,000 objects orbiting the Earth, such as satellites and used rocket boosters, that are large enough to be detected and are traveling faster than the speed of a bullet. Hundreds of thousands of additional objects orbiting the Earth are too small to be detected using current technology, and these numbers will only increase. Satellites, such as those used for GPS and weather forecasting, are constantly at risk of colliding with and being destroyed by these objects. Now imagine taking a piece of string and forming a slightly stretched circle, or ellipse. This is what the path looks like that a satellite follows during one orbit around the Earth. Each of the 22,000 objects we can detect follows a path that looks like this, but each has a different size and shape. My dissertation topic is a new way to calculate the orbit for any object orbiting the Earth and to predict where that object will be in the future to help avoid potential collisions. The method I use approximates the size and the shape of the orbit. As shown on the right, this estimate is then updated and updated and updated until we find the final orbit solution. If humans were to remove some of the larger pieces of space junk, it would greatly reduce the possibility of collisions in space. I can calculate the orbit for a spacecraft that orbits the Earth in order to reach a piece of space junk. The spacecraft could then move the object closer to Earth where it would burn up in the atmosphere. But the main advantage of my research is that it may be implemented on modern parallel computers, such that most of the calculations may be performed simultaneously, which increases the calculation speed by 2 to 3 times. As the number of space junk increases, it takes much longer to calculate all of these orbits. In fact, it may eventually take longer to calculate these orbits than it takes the orbits themselves. In addition, if we can predict collisions far enough in advance, we can take action to prevent them. So the next time you pull out your phone and check the weather or find the quickest way home, remember that it's research like this at Texas A&M University that enables satellite technology to continue to work and to prevent a doomsday scenario.